Now that we have discussed simple interest, we can move to a conversation about compound interest. Compound interest is where you are going to earn interest on that original amount, but then you're also going to earn interest on your interest. So let's imagine that Deidre invests $1,000 in a savings account that pays 6% per year, and it's compounded semi-annually for 3 years. The first question that we have to answer is, how many periods are in each year? Well, it's compounded semi-annually, so what that tells us is that the year is broken up into 2 periods because it's semi-annual, half a year. So you think of semi-annual sales, they happen twice a year. So there are 2 periods per year. How many total periods are there? Well, since there are 3 years, you're going to have 3 times 2, which is 6 periods total. How much is in her account after 1 period? Well, this is based upon simple interest. So I will equal the principal, which is 1,000, and then the interest rate is 6%, and then the first period is 1/2 of a year. So we get $30. So how much is in her account after 1 year? Well, let's figure out how much interest is on the second period. So this time we're going to earn interest on not $1,000, but after 1 period we've earned an additional $30. So our principal is now $1,030. Now, in case you're thinking this is going to take forever, you're right, but we do have a formula that will shortcut this. Notice this is a warm-up problem, so this isn't necessarily how we will work problems from here on out. We have a formula that will shortcut this whole procedure. So after 1 year, well, the annual interest rate has not changed, and we are still looking at 1/2 for the duration of this part of the investment, because each period is 1/2 of a year. So now if we take 1,030 times 0.06 times 1/2, we get $30.90. So let's do the calculation for the entire investment, so all 3 years. So the beginning amount at the beginning of the period was $1,000. We earned $30, so the balance is going to be $1,030. That's going to be the beginning amount for the second period. The investment earns $30.90 based upon what we just saw, and so now we have $1,030 plus an additional $30.90, so we're up to $1,060.90. So that is the beginning amount for the next investment period. So what's the interest earned on this? It's always going to be PRT. So again, we're still in the warm-up. We have a formula that's going to shortcut all of this soon, but we're going to take 1,060 times 0.06, and a period is still only 1/2 of a year, so times 1/2. So after this period, we've earned an additional $31.83. Now we add that to the amount that we had at the beginning of the period, the $1,060.90. So we have now $1,092.73. So that is the beginning amount for the next period. So 1,092.73. So we take that amount and we use our principal times rate times time, and we multiply that by 0.06 times 1/2. And notice our interest goes up because we have more, so 32.78. And so we'll add our beginning amount to this interest and we'll get this amount. And so we get $1,125.51. That is now the beginning amount for the next period. Now, if this were simple interest, this center column would all stay the same because you're only ever earning interest on the original amount with simple interest. But we're earning interest on our original amount plus the accumulated interest before that. So what is the interest earned for the fifth period? Well, it will be our principal times our principal for this period, so $1,125.51 times 0.06 times 1/2. And that gives us, if we round, $77 because we round, 77 cents. Let's add these two amounts and that'll give us the balance at the end of the period. This gives us $1,159.28. So that is the beginning amount for the next period. So take that amount times our rate times our time. So we have our rate is 0.06 and our time is still 1/2. And we obtained $34.78. Add those two amounts together, the beginning amount and the interest earned for that period, and we get $1,194.06. Now, there are two problems with this method. One is, could you imagine if you made an investment of any significant length of time? This was 6 periods because we had 3 years and it was compounded semi-annually. Could you imagine if it were compounded quarterly, 4 times per year, and you did it for 10 years? So that's 10 times 4. That'd be 40 periods. So this would be really cumbersome. Also, we did a lot of rounding in this process. So we have a formula that can shortcut this. A equals P, the principal, times the quantity 1 plus the annual interest rate over the number of times compounded, and that quantity is raised to the number of times compounded times the number of years. So let's redo that warm-up in a way that would actually be feasible for a quiz or a test or something like that, and what you would do in the homework. You will never do that method that we saw in the warm-up again. So Deidre invests $1,000, so we have 1,000. Our interest rate is 6%, so 0.06. N is the number of times it's compounded per year, so that'd be twice because it's semi-annual. And T is the number of years, so we have 3. So A equals P times 1 plus R over N to the NT power. It would be useful to memorize that formula. So 1,000 times 1 plus 0.06 over 2 raised to the 2 times 3. So if we are going to write this out in our calculator, let's simplify one thing first. The only thing I would simplify before putting in your calculator is the exponent. That's easy, and it would only create problems for many students. So I just always suggest simplifying that exponent first. Everything else can be typed in your calculator as long as you're mindful of parentheses. So in your calculator, you would type 1,000 times parenthesis 1 plus 0.06 divide by 2, close your parenthesis, caret 6. And you will approximate, but it will only be a single approximation instead of several. So 1,000 times 1 plus 0.06 divided by 2, that quantity raised to the 6th power, should give you a number that was close to what we saw in our table. So 1,194 0.05. And that is the right answer. So this is very close to the amount that we saw in our table by 1 penny. So let's look at this. We have Allison invest $4,000. So P is 4,000. The interest rate is 3% compounded monthly. So 0.03 is R. N is going to be 12 because it's compounded monthly. And so we want to know after 20 years. So A equals P times 1 plus R over N to the NT power. So this gives us 4,000 times the quantity 1 plus 0.03 over 12, end quantity, raised to the 12 times 20. So again, I would simplify that exponent. And then in my calculator, we'll type in 4,000 times parenthesis 1 plus 0.03 divided by 12, close parenthesis, caret 240. So what does this give us? You should get $7,283.02 after we round.